and we're live. So for tonight, what I had planned for us was to give you a brief introduction of writing a GUI application, which means graphical user interface with Java, so you have an experience with that as well. Probably we'll take the first half of the class. We're going to do an example together. It'll be open lab for you to work on whatever you need to work on, and Brent and I will be here to, I guess, answer any questions you might have. So that's the plan. Any questions, complaints, concerns? All right. So as I mentioned, the GUI stands for Graphical User Interface, and the Swing is probably the most popular library available with Java to develop a GUI. There are some other libraries as well with Java. AWG, which stands for the Abstract Window Toolkit, is one of the older libraries. It was built on native, so it did, essentially brought up the forms and the GUI elements from the operating system, which was good, but it was also dependent on the operating system, so then if you were trying to display on a different system, the result could look pretty bad. So then enter Swing. Swing was developed to resolve this problem. The Swing graphical user interface elements are developed with Swing, not with native, and they are also more advanced, so there is more variety. And at some point in the past, Swing was a bit slow to use, but that has been corrected as well. And frankly, I think more of the purpose of this lecture is more to introduce you to the fundamentals of GUI in general, because I don't think there are many jobs asking for you to build a GUI with Java. Java is not primarily known for GUI, but it is available here. And a couple other libraries to mention, JavaFX was developed historically around the time when Flash was active, so that didn't go very well. And Pivot was developed to compete with FX, so these two are still around, but not very much. And therefore, we're going to learn how to code our little GUI form with Swing. This is the Swing inheritance hierarchy. So again, we're following our inheritance as we have learned in other classes. We start with a couple abstract classes. There is a component, and the component has a container. So a container can be anything that can contain other widgets or other containers, depending how far you take it. And so note that we have two subclasses that come out of the container. One of them is the window and the frame, and the JFrame. These are the AWG, so this is the old library. However, the JFrame is part of the Swing. As I have commented today in a couple of classes, the choices of abbreviations and names are very interesting always when it comes to programmers. So the J is for Swing. Well, it's for Java, but it means that this is a Swing component. So the J component is going to have in it, it can have a label. You might be familiar with some of these from other classes that you took. So the label allows you to write a description of your widget. A text field allows you to do what? Do you know?
Enter text.
You can enter text. A button, I think, hopefully we all know what the button does. And then there are actually other components as well. And then the JFrame is actually the frame which is going to be the starting point of your GUI. So you start a frame, and then you add components and subcomponents inside this frame. Here's what an empty frame looks like. And the package which we're going to need to import is the javax.swing. The javax class package contains newer classes. So the Java was the older one, and javax contains the newer classes. We're going to learn how to change here the text, but this is the default look, pretty much an empty frame. And we are also going to add a panel, which is a container for buttons, another couple buttons, and we're going to make the buttons respond to events, which is a fundamental skill when working with GUI. You need to respond and handle user events. So we'll make these buttons print something on the console when you click them. And that's what they have planned. And the exercise from the book is pretty involved and complicated, so we're not going to do that. I did another one, which is, I think, a shorter, more concise version, and I posted it in week 11, but we're going to hand code it as always to get some practice. So that's all for the lecture part. If you would please start your Eclipse. Oh, and also to let you know, we're going to see it implemented, but it's, I think, pretty fun. We're going to handle the two events for the two buttons. One of them will be with the syntax before Java 8, so with anonymous class, and then we're going to have an opportunity to also handle the other button with Lambda Expression, so you get another review, if you will, of these notions. So we're starting a new project. Let me start magnifying. Okay, so is everyone ready to start? Yes, Christine? I don't know. Let's see. You probably do. So maybe no one used it before. So you need to go in program files, folder C, program files x86. So x86. Eclipse. Double click, and then. All right. All right, so we're going to start a new project. And we can name it GUI example. Example one, GUI example one. Well, it's loud out here. It's only going to be one file, but because it's a GUI in which we can create a package, and you can tell me which package you should go to.
User interface.
We're going to create the UI package. UI. And the new class. GUI example. One. It will have a main. Here we go. All right, so the steps, generally speaking, when you create a GUI, are first of all, you create a frame, which will be the main window of the application. Is the main window. I'm just adding the comments, right? And then we're going to add components. In our case, we're going to add a panel. And we're going to add buttons. And finally, we're going to handle the events on the buttons. Okay. So for the frame, it's a class. So the class is JFrame. We're going to name it frame is equal to a new JFrame And then that's where we give it the label with the text that is going to get displayed on top of the frame. So, for example, GUI, very creative, I know. And we're going to be importing all kinds of classes here. So when you see your light bulb, you can import JFrame in this case. So next we're going to set the size of the frame. And these are all, again, methods and properties that we're calling on the object. So we should be, it's all the same principle. So the frame, oh, wait, see, what is the problem here? No problem, okay. So frame dot set size. So you can see also there are so many things you can do with each of these components. If you scroll down, there is a large number of methods and properties, but right now the one we want to call is set size. And we're going to set it to 600 and 400 pixels. It's in pixels. Next, we're going to tell where the frame is going to open. The location of the opening of the frame can be determined essentially by the operating system. So we're going to say frame.set location by platform. And we're going to pass it through. So we do want the operating system to handle this for us. Next, we're going to call a method called setDefaultClose operation. And I'll explain in a moment here. And we're going to set it to jframe.exitOnClose. So you have different constants here. The one we're going to use is exitOnClose. And the reason why doing this is because if you click the X on the frame, it's going to close even if you don't add this line, but the application will still run in the background, so that's a problem. So if you use exitOnClose, then it's going to close the application as well. And that's what we want in this case. And next we're going to write some code to tell the program that we want to use the look of the operating system. So the following lines of code are going to set our frame to look like the operating system, which in this case is Windows. And we had a lot of issues in the previous section with there are a lot of braces and parentheses, so I'll try to go more slowly. And just be careful, it's also hard to see, but we have some interesting syntax coming up here. So we're going to do this in a try and catch block. So try, we're going to call a program, a method object, UI manager. Dot get system look and feel class name. So close the second parent. So just a second here. Okay, right. So then we're going to close the.
It's supposed to be a curly brace at the beginning.
The beginning is a curly brace. Maybe I should put it in a separate line to be more clear. So it's the curly brace opening the try. And then we have the class UI manager, and we call a method get system look and feel class name. Okay, I know what the problem is. I'm missing a line here. So actually we need to call first set look and feel. So please go one line the first line in the try block needs to be UI manager set look and feel. That's what I was trying to do. Set look and feel. And part of the problem is that the Eclipse tries to add parentheses where they don't need to be. So here, the set look and feel, we only want the opening parent, because then the other class and the other method from this class will be passed in as a parameter, if that makes sense. So UI manager get set look and feel, and then opening parent. And inside that parent, we're passing a parameter, an argument. UI manager get system look and feel class name, which doesn't take any arguments, so we're going to close it. And then we're also going to close this bracket, this parent here. So it's like one opening and two closing parents and semicolon. And you can look up always the methods that we're using. So the set look and feel. And again, just to clarify here, so essentially in Java, it's very common. You have to call several methods like this to make something happen. And it's like a pattern, design pattern, if you will. And this is the pattern to set the look and feel to the operating system. But each of these methods, you can look it up. However, just looking up the one method is not enough to solve it. You have to know the sequence or the pattern. But this one loads the look and feel specified by the given class name. So that's what we're doing. We passed it a class name. And the class name we passed it was the system, the operating system look and feel class name. And then we're going to catch the exception. And in fact, there are several possible exceptions. So we're going to be separating them with an OR. The first one is class. Let me make sure we have all the brackets. So you close your curly brace here for the try, and then you catch, and then you open parent, class not found, exception, or illegal access exception. And we are going to have to resolve these errors. We need to import these classes. Or instantiation exception. Did I spell this correctly? Instantiation exception, or unsupported look and feel exception. And then E, the name of the exception. And somehow I have an extra parent here that we don't need. But after the exception, you open the curly brace. And so the way we're going to handle the exception will be by printing to the console. So system out print line, unsupported look and feel. And we need to close the catch. And we need to import unsupported look and feel exception, and the errors should go away, or otherwise we can look and see how to fix them.
Can you scroll a little to the right?
Yeah.
Yeah, thank you.
Here you go. Let's see here. Is anyone having any syntax issues at this point? Okay. So what we need to do next to see the frame, if we run it right now, we won't see it yet. What we need to do is say frame set visible to true. And this should allow us to display the frame. And there is the first frame with the text GUI example. So there's our GUI. And back to the code. Are you ready to continue? Is everyone caught up? Okay. Are you redoing this? Okay. We should probably do this. How about we all do this actually? Okay.
Can you
Yeah.
put the mic aside?
Yeah.
Sorry.
No, it's fine. That's what we're here for. So you have syntax. On line 21, click on the little
Sure.
line over there. And say import, I think it's not actually. So maybe we just need to Okay, so then.
So I was hoping it would show me when I floated over the error instead of that. Yeah, that's okay. Okay.
Yeah.
Thanks, Tom.
It's the X. If the X has a little light bulb, then it means you need to import prod or something. Okay, so these are a couple exceptions that are thrown when the application tries to load in a class. Class not found. This one is probably pretty obvious by the name. Illegal access exception is thrown when the application tries to reflectively create an instance or set or get methods or do something to a method, but the currently executing method does not have access. So you're trying to access something that is not in your scope, or for some other reason you can't get to it. Instantiation exception thrown when the application tries to create an instance of a class using the new instance method in the class, but the specified class object cannot be instantiated. So maybe you're instantiating an abstract class, right? And these are all things that can potentially go wrong in this scenario. That's why we have to handle all of them. And then unsupported fill and look exception indicates that essentially the classes are not available. You're trying to load the look that is not available for this particular setup. Okay, so everybody was able to display the frame? All right. The next step is going to be to add a panel. And so the panel is essentially an invisible container. It's a container to contain other elements or other widgets, but it's just there invisible. And what you need to do is, in order for this to work, you actually have to put the panel and the buttons before the set visible. So what we can do is copy this code here down to copy our comments. And we're going to move them up here since we're doing this before the set visible. And so adding a panel is the next component. It's called a JPanel, the name of the class. It's a string class. Panel is equal to new JPanel. And we need to import this as well. And now we're going to add this panel to our frame. So frame.add, and then we're going to pass it the panel. Oh, that was the wrong method. We just want add. All right. And we should have a panel now. If we run our application, there should be no visible difference here, but we have added it. And the reason we added it is because we want to add a couple buttons. Well, you can guess the name of the class for the button. Button is the AWT. That was a good guess, but we're using swing, so that means everything is prefixed with a J. So it's a J button. Yeah. J button, button 1 is equal to a new J button. And we're going to pass it the label, or it's not really a label, but the text of the button, which will be, let's say, click me. And again, it can be, of course, whatever you want it to be. And one more, I guess we need to import here, J button. And button 2 is equal to new J button. No, click me. And now we need to add the button to the panel the same way we added the panel to the frame. So it's going to be panel.add button 1 button 2 and sure enough, here are buttons. They don't do anything yet though, but they're here. All right, and so the last part of the demo is going to be to make the buttons handle events. Handle, when we click on the button, it's going to do something. And we're going to do this in two different ways. We're doing it two different ways just to show the Java 8 versus the previous, but you can do it in the same way. Normally, you would probably use just one approach or the other, depending on what version of Java you're working with. So that's just for illustration purposes. And the first one is going to be handle the button with a Lambda expression. So that's Java 8 and newer whenever there's a newer version of Java. And here is the syntax. And I'll talk about, well, maybe I should talk about what is going on first. So, so when you click on a widget, in this case a button, you have something called an event listener. And the event listener, and this is not just for Java, by the way, it's a more general model. So when you click on a widget, an event is triggered. And what you need to do is you need to have a code called event listener, which is going to listen for the event. And then the event listener is going to call the event handler. The event handler is normally the code you write to handle however you're handling the event, right? So we have an event listener, and event handler. And those are what we're going to use. The event handler will be the code we write, and then the event will be the click, which is part of the Java. An event can be, of course, something by the operating system, so that's another topic that is more general. And then the event listener method will be from the Java API. So that's what we're about to do next. And this is going to be on the button 1. And we're going to say add Actionlistener is the name of the method. Essentially, what you'd call this is that you registered button 1 with the Actionlistener, so it's now able to wait for the event to happen. All right, so let me finish writing this here. And so the add action listener method is actually going to take action event, which is a class, E, and we're going to call on it a lambda expression. So if you might recall, the arrow means we have a lambda expression going on here. And then our custom code is going to go inside the lambda expression. And I'll deal with errors in a moment. So system out print line button 1 was clicked. And the action event object is essentially going to be your event object. We have it, we're going over something similar in the JavaScript class. The action event object contains method and properties related to the event. So let's look at these errors here. Okay, first of all, this is a lambda expression. So to close it, the closure syntax is a curly brace semicolon. And now we need to import the add action listener. And oh, it's importing now. Okay, so it seems to me like you need to actually complete the lambda expression before it allows you to import it. But you need to import add action listener, and the errors should go away. Just be careful for the syntax for the closing of the lambda expression. And if we look at the description here, add action listener is a method which returns a void. It takes an action listener object. It's an interface. And what it does is adds an action listener to the button. So in other words, we can also call it that the button is registered with the action listener. And the action listener, didn't want to open the whole thing here. It's a little easier to see like that. Is a semantic event which indicates that the component-defined action occurred. This high-level event is generated by a component when the component-specific action occurs, such as being pressed. Oh, I should mention that with the events that we can handle with the button in this setup are not only click, but also mouse. If you press enter, it's going to respond. So it's wired to handle a couple of different events. Let's see, anything else to point out here? Oh, you can also use a spacebar. So we should test that. Okay. So let's try this. So button 1 now should be responding to the event, and sure enough, our response was to print button 1 clicked. So when I clicked on it, it printed button 1 was clicked. And when I pressed the space bar, it also responded. And when I press enter, it also responded. So 3 ways in which you can trigger the event handler of the button. All right, so this is the syntax for the Lambda expression. Essentially, if you recall, we use an interface. This is the event object is an interface, and then we use the Lambda expression notation. And in this case, the response is down to that through here. So let's add the last part of our example, which is handle events for button 2 by using the syntax prior to Java 8, which is using an anonymous class. Okay, so handle, the comment is going to be handle button event with an anonymous class. Okay, we're going to again start with, in this case, button 2 dot add action listener. So we register our button that is listening for events, and now the difference will be that we're going to use an anonymous class. So we're going to, in this anonymous class, create an action, new action listener method. Let's see. I think we have to finish typing for some of these errors to clear up. So we have a new action listener, and then opening and closing parent, and then curly brace. And here we're going to write a method, namely public void action performed and this action performed is going to take the action event E, which was also used in the previous example, but with a different syntax. And then this is where we're going to say system out print line was clicked. We have too many braces apparently, so let me start clearing out some of these errors. Oh, well, the first issue is that we have an anonymous class, so again we need to make sure to close it not just with a curly brace, but parent and the semicolon. Okay. I need one more brace here, and let me look at these errors. So like I have some kind of syntax error. So let me just take a look and see what is the problem. Okay. Okay.
Can you report the action listener?
I did for the first example because it was also using it, so it's there. Oh, maybe I didn't. Huh. I thought it did, but oops. Yeah, you're right. Let me do it. It's not letting me.
Yeah, I didn't want to do it.
Just do it the easy way, click on the error.
This is in the event as well, correct? Yeah. So why is it not? There we go. Event and action. My keyboard is off. It's fine. Action. Okay. So save all. And that was it. That was weird because we used it in the Lambda, so I guess maybe somehow somehow it was removed because it certainly was working with the first example. Okay, well, let's test this out. Okay, button 1, no click me. Button 2 is clicked, spacebar on button 2. There it is. And this concludes our example of developing a GUI with Java. Of course, there's a lot more you can do. Do you have any questions? I'm sorry?
How did you take care of the error that's on the button?
I took care of it by importing the action listener, which for some reason had unimported itself. So just manually add it on top, or I can come and take a look. Let's see. Probably want to see the code. All right, let me take a look and see. I was also going to issue this in the previous section. I think it's, yeah, that should fix it. So if you move it in. The override has to be X and not small. Yeah, I guess it was unhappy because you can't pass an interface without overriding the methods as well. So actually, one of the other reasons I'm really glad we're doing this example is because hopefully it shows you practically how the Java API uses the interfaces and inheritance and all these concepts that maybe seem a lot more abstract while you're working on them, but as you can see, they used.
This will run under Linux too, won't it?
Yeah, it's supposed to run in different operating systems, that's right. So that's all for this demo. I'm going to close the recording now, and then we're going to have Open Lab. So take a break as you need to, and then work on whichever project you work on.